Looks like it's up there.
Okay.
And this lubricates the entire machine. Look inside here. Yeah, it's full. So you got a manual one, but this one's completely automatic. All right. First of all, let's see if we can. Okay, well that's the three-phase converter. Down the middle. That noise you hear is the hydraulics in there. That's where the hydraulic fluid is, the reservoir. In there? Yeah, there's like a 15 horsepower motor that runs that hydraulic pump in there. And that pumps through these hoses up to the hydraulics up here, which actually turn the spindle. And right now, we've got a high-speed spindle on there, so we're not even using any of those hydraulics. This is run by box over here. That's the power supply. That's also three-phase. That's a variable frequency drive, and that'll run this spindle from I think 5,000 to 20,000 RPM. But that's not part of the machine. It never came with the machine. The spindle, I believe, is 200. No, it's 180 to 2,000 RPM.
So this and this you purchase separately.
Yeah, it's a Technara high-speed spindle is what it is. And we got it because we use tiny little mill bits to do work on there. And obviously 2,000 RPMs is nowhere near what you need. So, let's see. I think that's, I'm not sure how that actually.
Oh, while we're waiting for it to warm up,
Yeah.
why don't you explain to them how you got it in the shop?
Well, basically it came up from Kansas, and that was on a flatbed truck. And we hired a crane operator from Chippewa Falls to take it off the truck. And when I took it off the truck, I had some, I think, 2x4 tube steel, quarter-inch tube steel beams that I had laid on the ground right in front because it's a gravel driveway or whatever. So I put 4 or 5 beams down, and then I put cold rolled or whatever, just rolled steel rods, probably 3/4 inch, and then another layer of the tube. So once the mill was set on those tubes, we actually pushed it by hand most of the way, and then we just took, once the roller was done, we put it in front, and then those rollers rolled right on the concrete and pushed it all the way in. Because there's no way, I mean, we could have gotten it in here otherwise, but that worked pretty good. Basically, there's just a three-phase motor down there. That's 20 horsepower. And then in here we just have
Old refrigerator.
yeah, it's just an old refrigerator. But in here we have a starter circuit and all of the capacitors we need to basically create the third leg, actually just delay it a little bit. And that's about it. It's a mess, yeah, but it works. And we have to use this three-phase converter to run all the other equipment in here. Everything else is three-phase, the
Bridgeport drill.
cold Chester over there, I believe. No, that's a Closby.
Lathe.
Closby Colchester, yeah. And then of course this big old drill press, that's all run on 3-phase as well. Yes, it's an electrostatic discharge machine. And this, the CVTC had it while I was actually there. We ran it, we used it. But they upgraded, they got a couple of other sinkers and wire mediums and stuff. So they put this on the southern. Actually, the drill press over there is from the CVTC as well. The lathe is from Hutchinson Technology. This is from some place in Chippewa Falls, a powder coating place. They didn't need it, so I bought it from them.
So, on this EDM, it's actually these two pieces, right?
Yep, that's the brains of it.
That's
and
the brains.
This is what happened. Because there's a cooler back here. This is actually filled with the coolant that's still in here. I think it's like 40 gallons of the dielectric that they use. So, because all the work is done underneath that. Okay, so now basically the hydraulic pump is actually running. And what I did was I engaged the low gear here, and I'm going to turn on the there's a switch over here. Once we turn it on, so the fluid actually goes through all the pumps. So the fluid is coming through that pump, all through the lines, through this drive pump here.
How full should this be?
That's just a cover. You'll have oil in there that will fling around, but that's not something that you fill up. Control for it.
Like that?
It's a speed control for it.
Okay.
So if you look over there, you'll see the gauge. So we're at 240 RPM. You're looking at the low. Since it's cold, I'm not going to go anymore, but I'm going to put it into high speed. So to do that, we turn it off, of course, over here. And then put it into high speed. And then we turn it back on. Now we're at like 650 RPM already. The same thing. All this stuff is fully functional. Everything works. There's no leaks. And right now, every so often, it's got a motor that's got a cam and everything on the automatic lube. So that it'll lube and it'll give every area lubrication. So, what else do you know about this? We got your X-axis, which is the table. Which is this actually, the bridge back and forth. It's all ball screw, large ball screws too. And then the Y is the table. Back and forth. And then of course up and down is the Z. Handle's a little stiff, but it was designed to do, it's an NC mill, a numerical control mill, and it's got little chips on cards in there where you can program and it'll do your thing. It's an NC copy mill, so it's also designed to have like a prototype on here, and then the stylus is supposed to follow it back and forth as it actually mills things out. It does work, but I never did like a full part or anything. I know if you start it up in there and you move it back and forth, the mill moves back and forth. The table and up and down and stuff like that. That probably needs some fine tweaking. The way I would use it is, and a lot of the times the way we did use it is you had a computer connected to it and you get, it's called a servo to go card, and that control up to, I don't know, 8 axes or something like that. And that uses the feedback from these encoders, which we added on each axis, we added them. So that gives you your feedback, their quadrature feedback, A, B, minus A, B, Z, minus Z, that type of thing. Obviously the computer's not here anymore, but probably because it's so old. And we use a program called EMC, it's Enhanced Machine Code, and it's free. You use a Linux platform, and all the information down there. A bunch of retired CNC guys got together, and they were sick and tired of all Haas and all those other places charging you ungodly rates. So you can download this for free. Linux is free. You can put it on there. Just read their manuals, and they have forums and people who will answer your questions. They even answered my questions on Sunday, so that's pretty cool. But if you're just using it for a manual mill, that's perfectly fine too. Yeah, I don't know. All the motors and stuff on here everything's good. Before we got it, apparently Boeing owned it. And before they got rid of it, they kind of upgraded or replaced all the servo screws and stuff like that on it. So all these ball screws are brand spanking new. Very little play in them, and with the computer you can get it down to 1/10,000th of an inch, so 0.0001 for accuracy. That's better than what they advertise. They advertise 0.8 of a thousand, so 0.0008, which is still pretty phenomenal. Yeah. That's 1,000 RPM, and it's still full, so I'm not going to go any faster than that right now. It does go up to 2,000 RPM. It does have a one of these here. Oh, this one here. So you can have cooling. It's got a tank back there. So basically what happens, and of course we drained it because it's the winter time, but the cooling will come out of here, it'll go in here, it'll drain down. It's got little rain gutters that go back down, and it'll filter it, and it just recycles the whole thing. That motor we had to actually send in and rebuild, but that was done by, I forget who did it, but some professional. We could probably open up the control pad. Yeah, take a look inside here. So this is where all the magic happens. If you can get the door open.
Can we shut this off so we can hear it, or should they leave it on?
Yeah, I could turn it off.
Okay. That's better. I can hear you better now.
So that's running at 10,000 RPM right now. Let me turn this off here. It's so smooth. That's why this thing, a new, costs 15 grand.
Just this piece here?
This, along with the controller.
Call it. Okay, so this is the guts.
Yeah. Should I set everything else off or what?
Yeah, if you want. Yeah, go ahead. So, everything is operational at this time then, huh?
Yeah, as far as a manual mill, it's not a CNC because there's no computer telling it what to do at this time.
But you can make it into a CNC?
We did, yeah.
Okay.
Actually, I got a video online that shows it. What I ended up doing was I made some of these handles here, and I made them out of brass. And what I did was I used, we had Mastercam running this mill, and I used the Mastercam lathe program to start it up. And I actually put, I had anyway, a chuck in there, and I used this as the spindle of a lathe when I used the lathe program. And I had all the tools mounted on the table, and I used the tools to make the parts in there. I should send you that link too. So, okay, let me shut that off.
So this is the guts.
Okay, yeah. So let me put this, turn that off too.
There's a lot of stuff in there.
Okay, so let me point some stuff out in here. So basically this is like your controller side, and you've got all your transformers down there. Those you can rewire. When we got it, it was set up for 480 volt three-phase, and we don't have that. So they're jumpered in a way so that everything, all the motors and everything, I run it on 240 then. So you've got, these are the servo controllers. So you've got X, Y, and then Z has two of them because there's two Z motors. All of these are the controllers that actually control, your inputs from your encoders on your hand, like right here. There's glass encoders in there, and it takes that quadrature signal and goes through all these boards, and that's what controls the servo. The input goes to the servo. There are schematics for this, which if we didn't have any, I'd be lost.
Where are they?
They're down in here, I believe. I'll have to look. But everything's labeled, which is fantastic. Some of these cards are used specifically for your NC programs, which they're in there, but I'm not using that.
Didn't you guys have to buy a new $600 board for something?
That was I think that was the servo board.
Where does it go?
That goes into whatever computer you have,
Also, it's for the computer then.
Yeah.
Oh.
Well, I'd like to get on this side, but you can't. On the back side is all the controls for all the motors. It's the relays that start and stop the motors and stuff like that. So
Yeah. Oh, that would be back here, in there somewhere. Okay. Yep. A shop only has a limited amount of space before it gets full.
exactly. So this we could put in the box
Okay.
because we're not using it today or whatever. All of this is just looped around that comes right to this controller. But we have the actual original box for that. That the company obviously sends with it. Oh, moly. That is pretty heavy.
And the collets go in that box too?
Yep.
Okay.
Well, they were in here. Yeah, you can see it down there.
Oh.
This is how many it came with. I bought a bunch more for it.
Okay.
You know, I think I bought the standard because it only came with metric.
What is this called, actually?
It's called a high-speed spindle.
Okay.
Actually, that's how I found it. It even says right on the side here. I looked for it on eBay and I couldn't believe I found one. This one's well, here you go. There's a Technara. That's the name brand of it. Okay. High spinner they call it, but it's a high-speed spindle.
All right. So that's pretty much about it then, right? For now.
I think so.
Oh.
Yeah, it's a fantastic machine. There's it's quite amazing. This is designed so that if you found yourself another head like this, you could put it on there. This head does tilt. It does. I think you can adjust this up and down, left and right, depending on what you need to do. Actually, I'm not sure if it tilts or not. I guess we never had it tilted. Yeah, it does move back and forth. And I've seen pictures of this where they have two heads, so that they were using the stylus to trace something, and they were making two parts at the same time. So,
Okay.
this one actually has a readout on it too, which we probably should have powered that up to make sure that goes. But yeah, so
You want to?
we can, yeah.
Okay.
Go ahead.
I'll just.
Okay, lock those in right away. But if you don't lock them in, they kind of drift. And I remember one day, this was just idling like this. We weren't running anything. And Jim had a really nice Kennedy tool chest that was sitting on the table. And we were over there, and every now and then we heard crunch, crunch. Well, the Z, because these weren't locked in, the Z kept creeping down a little bit, and we just crushed that thing down. I'm sure it's around here somewhere. It's in bad shape, but so that's why I lock them in right away. And we were gonna turn this on.
So how you just push that to lock them, or?
Oh well, okay. So usually it's in manual, and nothing happens. There are different functions. I don't have the operator's manual. I tried to get one. This business said they had one for $500. I sent them $500, and they go, "Oh, we don't have any." So I never got an operator's manual.
You never get your money back either?
I got my money back.
Oh.
But yeah, but we have schematics, and that's the important part. So anyway, in order to lock them, you would select any one of these really, and then you just twist it, and it grabs the signal, and then now it's locked in.
So all three of them are locked right now?
Yeah, you can see the lights come on when they're locked in.
Locked.
When they're not locked. Okay, so here you'll see the light pop on.
Now it's locked?
No, it's locked.
Okay.
So that way it knows where it's at and everything. So I'm not sure if
Yeah, what about this?
or not.
Oh, you gotta plug this guy in, okay.
Yeah, here's the plug.
You got power. I got power over here if you need it.
Yeah, I need power.
What's that?
Just power.
Can it reach?
No.
It's like Da Vinci.
Okay, so that'll tell you your Z. This is an invaluable tool to have. You can't buy these things anymore. Well, you can, but they're very, very expensive. It's a Sony. It uses it's a Magnascale. This one's LM22, and it uses a sinusoidal feedback on there. When we got it, it only had X and Y, so we decided to add a Z access to it. So there's a Z on there, and we bought a new box for it too. But it's you know, it goes down to 1/10. It's pretty darn accurate like that, you know. Now let's see if I go to manual. Now you see, look at the numbers now.
Yep.
It's drifting. The Z is actually doing something, and now that one is too. That's why, you know, you want to lock it in, and then it's solid. It doesn't move. So there's probably some adjustment on there that you can make that whatever, but that's not the way we use it.
Oh, that's cool. That's very cool.
Yeah, you should look that up on the internet, and you'll find that it's probably $500-600 just for that.
Really?
You know, and then another couple hundred for each of the scales.
Wow.
You can find some deals now and then, but it's tough to find a 3-axis one.
Really?
Yeah.
Not even new? You can't find.
Yeah, you can buy them new, but nobody uses a magnetic anymore. And
Oh.
by the way, the reason why this uses magnetic is because you could dump oil on it, and it'll still work fine. It's a magnetic scale. It's just the best that's for this environment. And another reason that this is the best for this is because the temperature at which this scale is at is the temperature in which all the metal is at. So as the mill warms up, all those things are going to warm up. It's even though you're supposed to kind of keep it at 68 all the time anyway. That's why they're the best. You get glass scales and stuff, and you get any kind of dust on them, like matte machine.
What, this one here?
Yeah.
Okay.
And because they're sealed, and if you get any dirt and stuff on there, they don't read properly. These will read with dirt, dust, everything on them.
Wow.
So that's why these are really, the best, I think. So, Magnus Scale LM22.
Cool. Thanks for showing that to us.
Yeah.
All right, that pretty much wraps it up, yes?
I think so.
I mean, just the gist of everything, you know?
That's the gist of everything, yeah. I'm sure there's a lot of functions here that, like I don't even know what all this stuff does, but I think it's for when you're using the stylus, and there's specific things that you can do, like the path of the cutter, High-speed spindle goes from 5,000 RPM all the way up to 20,000 RPM. It's the Technara. It comes with a set of collets with it. I think that's all metric. I think that's all they sell. Here's the controls for it. The main power, speed control. This is something that you'll start up and you'll run like for 5 minutes to get it even warmed up. But here's the frequency drive. I'm going to hit the start button or the run button, and you can see so just let that run for a while, and then we can crank it up later, but let it warm up. What I want to do is engage this.
That won't be good.
We got it in the low gear. So I'm going to actually turn on the hydraulic for that, and we'll spin that up. Actually, should we put a...
Here's all the extra stuff that... yeah.
This is just for the demonstration. You don't have another one of these.